Okay, now we're going to start into section 2.2, which is the addition property of equality. And the addition property of equality basically kind of boils down to one basic idea. And basically, with the addition property of equality, it allows you to come up with a solution set. And the reason I say set is that the answers that we're going to use are generally we come up with a singular answer, but occasionally we will have multiple answers that will solve our questions. But those are more with inequalities. And if you remember, our inequalities only make up a little bit percentage of what we're doing, and mainly we're trying to always solve something. So our answers are going to come down to just to one answer. But anyway, a solution set is just all numbers that are used to make an equation true. Remember here, the key word here is equation, so we're trying to equal something. So generally we're trying to come up with a single answer. Now, basically the rule that this all boils down to, and you've heard me say this over and over and over, is basically you need letters on one side and then numbers on the other. And what that means is we're just trying to get our variables on one side of the equation on our equal sign, and then we're trying to get the numbers on the other. And that's not always the way you do it, but that will solve 99.9% of your problems that we have. It will solve all your problems in this particular class. So if we're just looking at this particular one, and I'll just come up with one, x plus 2 is equal to 5. And basically this boils down to our using the opposites. So in order to get a number on one side, and we've done this with some of our, if you think about our complementary angles formula, it's x plus y is equal to 90. So this is something that we've kind of done before. So this is something that should be easier. So letters on one side, numbers on the other. I generally just always leave my variables on the left. If the variables are already on the right, sometimes it's easier to do it that way. But I just generally just like to see it that way. Once again, it doesn't have to be done that way. It's whatever works for you. So in order to move this positive 2, I use the opposite. Opposite of positive 2 is negative 2. Whatever I do on one side of the equation, do on the other. You hear me say that over and over. Just like with fractions, whatever you do on the bottom of the fraction, you do on the top of the fraction. So 2 minus 2, this allows that to disappear. And then 5 minus 2 is 3. And then, of course, this is your solution. Now, it doesn't matter what we really change these to. So for an example, if I say 3x minus 2 is equal to, 13. Same process will work because this is a negative number now. I use its opposite, which is a positive 2. Whatever I do on one side of the equation, always do on the other. By doing this, it allows you just to remove the numbers, and then you just have your letters on one side. So once again, this becomes 3x is equal to 15. How do I solve that? I basically divide both sides by 3. Or really, I'm multiplying it by the reciprocal, but it's easier to divide sometimes than to do the extra step of that, and that's generally when you have fractions. But anyway, by doing that, this allows you to come down to a single x. And remember, we're always trying to solve for x, not 2x, not 3x, not a half of x, or anything like that. So 15 divided by 3 is going to give me 5. And then I know that's my answer. Now I can go back and plug that in by doing evaluation. And once again, I just substitute in that x for a 5. And then I just see if this will make this true. And it should, because if we did it correctly, then it should come true. So 3 times 5 is 15. 15 minus 2 is in fact 13. So I know that this is solved correctly. And it's important to go back and check them from time to time. Now, if you had fractions, it's probably not. You don't want to spend all that extra time in going back and looking at them. But for your whole numbers, a lot of times that's just the easiest way to kind of work it out and to check it. So for our addition property of equality, and it doesn't matter which ones we use, this is really a short section, but if I use fractions, and remember everything in life doesn't come out nice and neat, but if I had 3/4 x plus 2 is equal to 5. Now, I'm not sure what this is going to come out to be because I just randomly picked some numbers, but it really doesn't matter. The process is going to be the same no matter what these numbers change to. Because this is a positive 2, I use a negative 2. Whatever I do on one side of the equation, do on the other side. This allows this to disappear, and that gives me 3/4 x is equal to 5 minus 2, which is going to give me 3. Now, because this is a fraction, my reciprocal comes into play. And remember, that's on every test that you see. And why? Because it's important, because it's used in almost all the things that we really solve. So the reciprocal of 3/4 is just 4/3. All I'm doing is reverse it. Whatever I do on one side of the equation, always do on the other side of the equation. So I'm just multiplying this times 4/3, and I just turn this into a fraction. It's easier if you do it that way because multiplying straight across is so much easier than trying to remember, oh, did this one line up with this number or this number? Just write it as a fraction, 3/1. It doesn't matter what this number is, just always slide a 1 underneath of it. By using a reciprocal, I don't even need to work that out, but it would come out to be 12/12. But anyway, it always gives you that single variable, and that's why it's important to use the reciprocal. 3 times 4 is 12. 1 times 3 is 3. And then, of course, our final, remember, we're still using our 3 magic numbers when we break our number down or basically factor it. 2 will go into both of these, but so will 3. So 3 divided by 12 is just 4, and 4 is going to be our final answer. And like I said, it's probably not time consuming, it's too time consuming to go back and then work these back through fractions. If this was a whole number, I would suggest you do, but because this is a fraction, probably not necessary. But if I use another one, so for an example, if I have 2/3 x plus 1/4, and all of that is going to be equal to 1/2. Now, at this point, I have all these different fractions at the bottom, right? So in order to combine these, I have to make sure my denominators at the bottom of those are correct. And this will be probably the most challenging one that you'll see. But anyway, the process is done just like with anything else. Addition property of equality, subtract 1/4. This is a positive 1/4, so I subtract 1/4. Whatever I do on one side, I do on the other. Now this allows this to disappear, and this just becomes your 2/3 x. Now, because these are unlike items, because they don't have the same denominator, that's 1/4 or 1/2 minus 1/4. And once again, my denominators have to match in order for me to subtract. So 4 times 2 is 8. So I'm just going to rework this one. This becomes 1/2. And remember, the 4 comes over here, just like when we were making equivalent fractions. The 2 comes over to this side. And this goes back to whatever I do on the bottom, I'll do on the top. So this becomes 4 times 4, 4/4. Remember, both of these numbers are 1. That's 2/2. 4 times 2 is the same thing as 2 times 4. So basically, I'm just working out that way. This is going to give me 4/8 minus, and 1 times 2 is 2/8, which is going to leave me with 2/8. Now I can reduce that down to 1/4. So I'm going to be left with 1/4 on this side. Once again, I'm going to do the same process. This is 2/3. So I'm going to use the reciprocal, which is 3/2. Whatever I do on one side, do on the other. And remember, I don't even need to work out the math on this side anymore. That's just going to leave you with a single x every time. 3 times 1 is 3. And then 4 times 2 is 8. And that's going to be your final answer. X is going to be 3/8. Now, to put this back in and work that out would really be time consuming. So I don't suggest you do that. Just trust your work and trust your answers.